Okay, let's look at question number 24. Okay, for question number 24, it says that PQR are distinct root of the polynomial. Then there is this real number ABC such that it satisfies the equation for all real number S, and S does not belong to these three numbers PQR. Then you are asked to find the value of 1 over A plus 1 over B plus 1 over C. I think these questions, you can do the substitution. You can rationalize it. You can rationalize it just like your partial fraction or your remainder factor theorem that you did with this equivalent expression. Therefore, in this case, can you see that from this expression, you can get this, right? That means this imply 1 is equal to A times what? Times S minus Q, and then this is S minus R, right? And then plus B, and then this would be just S minus P, and then S minus R, right? And then finally, that will be C times S minus P, and then S minus Q, right? This is what you get. Then in this case, can you see that you can substitute S, you can replace S by P, replace S by P, and with that, can you see that your B expression will be 0 and your C expression will be 0. Therefore, what you get is A would be just equal to 1 over S, okay, it will be A over P minus Q, then P minus R. Therefore, A equal to 1 over P minus Q and multiplied by P minus R. Then after that, you can replace your S by Q. You will get the B. Your B will be just equal to 1 over Q minus P, right? And then this is Q minus R, right? Then after that, finally, you can replace your S by R. That means S equal to R. Then you will get your C. Your C will be just equal to R minus P, and then this is R minus Q, right? Yeah. And can you see that now in this case, what does it mean? That means your 1 over A plus 1 over B plus 1 over C would be just equal to what? Would be just equal to P minus Q, and then this is multiplied by P minus R, and then plus Q minus P, and then this is Q minus R, and then finally that would be just equal to R minus P, and then R minus Q, R minus Q, right? Okay, and can you see that when you expand this thing, you will realize that please go through the expansion. You will be able to get this. You will be able to get this. I mean, the expansion is not difficult. Maybe let's just expand it. That means you will get P squared. Then after that, I think you will get minus PQ minus PR, and then plus your R squared. Then let's look at the second expansion. That will be just equal to Q squared minus PQ minus QR, and then plus your R squared. Right? And then finally, let's look at the last expansion here, right? Look at the last expansion here. Can you see that that will be just equal to that will be just equal to what? That will be just equal to R squared, and then minus PR minus QR, right? And then can I say that this is plus PQ, sorry, PQ. I think I make a mistake in this part here. The last term, I think I'm not very careful. This is actually QR, right? QR. And then this part here is PR, right? PR. Right? Okay, therefore, in this case, can you see that you can make them into a perfect square, huh? Can you see that in this case, can you see that this is what? This is just equal to P squared plus Q squared plus R squared, right? Therefore, in this case, can you see that what you have would be minus what? In this case, can you see that you will get minus PQ minus QR and then minus PR, PR, right? Therefore, but the thing is, can I make this a perfect square? Or can I make this in this form? That means this would be P squared. This would be P. This would be P plus Q plus R and then bracket square. Therefore, I should take away the middle term, right? The middle term is 2PQ minus 2 QR, right? That means in this case minus 2QR and then minus 2PR, right? But the thing is, originally you also have minus PQ, right? Minus QQ minus QR and then minus RP, minus RP. Therefore, in this case, can you see that minus RP or PR, right? Therefore, what you get is really P plus Q plus R squared minus 3 times of what? 3 times of PQ plus QR and then plus your RP. I think that's why I say you be patient, you expand, I think you'll be able to get the expression, right? And okay, I think can you see that S is the root of the equation, right? Is the root of the equation. Therefore, in this case, can you see that this part here? Let's go back to the question. Let's go back to the question. Okay. Can you see that PQR are the root? PQR are distinct root of this expression, right? Of this expression. Therefore, okay. Then in this case, can you see that? Okay, what is P plus Q plus R? Can you see that this part here? By your Vitas theorem. Can you see that by your Vitas theorem? This one, right? P, Q, R are the roots of the polynomial. Roots of the polynomial. That means in this case, can you see that? Let's write down the polynomial. Let's write down the polynomial. Okay, the polynomial given to us is x cubed minus 22x squared and then plus 80x, right? Minus 67. Therefore, if you solve this equation, can you see that what is the sum of roots? Sum of roots P plus Q plus R is equal to negative 22, right? Therefore, what you get is actually 22, right? Okay, then let's look at the product of roots. The product of root PQ plus QR plus RP, right? That will be just equal to 80. That will be just equal to 80. Therefore, once you substitute these two values, that means in this case 1 over A plus 1 over B plus 1 over C, right? When you substitute in, isn't that this is what you get? 22 bracket squared minus 3 times 80, or 3 times 80, and in this case what you get will be just equal to 244, and hence you solve the question. Therefore, I think this is really not so difficult. To just be patient. I think you should be able to get this answer. Right? Yeah. Therefore, the answer is B. 144. The 244. Sorry. Yeah. With that, I stop here.